And then the first question says, write down the equations of the asymptotes of f. What comes to your mind when you hear the word asymptote? What should come to your mind is undefined. And asymptote is that point which the graph never reaches, no matter what. So always, when you're given a hyperbola, let's say you're given a hyperbola g of x, and it's in the form a divided by b plus x plus c, and the question says find the asymptote. You focus on this part, on the denominator, right? And then you equate it to 0. B plus x equals to 0, and then you solve for x. This is because if you take any number k, right, and you divide by 0, you get undefined. So the graph will never reach that point no matter what. So for me to practice what I preach, let me do the same for our f of x, right? On the denominator we have x minus 3, which we're going to equate to 0, like I said, and then that will mean that x equals to 3. If you take this 3 right here and you substitute it in f of x, you are gonna get undefined, right? So the x coordinate of the asymptote is x equals to 3. But then the question says write down the equations. We have x, now we're looking for y. Like I said, if you substitute f 3 into f of x, you're gonna get undefined, right? So you won't get the corresponding y value. So what you can do is substitute a number that is very close to 3, x, our x coordinate for the asymptote. So what you can do is substitute 2.999999, or you can substitute 3.01111. If you do that, you're gonna realize that you will get a number that is approximately 2, and that will be the y coordinate of the asymptote. Using our example of a general formula of a hyperbola g of x, the x coordinate of the asymptote will always be equals to minus b, right? B being, this value that we have here, and then the y coordinate of the hyperbola will always be equals to c. So in this instance, y is equals to 2, right? And that's how you can sort of determine an asymptote. Let's move ahead. 5.2, it says write down the domain of the graph. The domain is every value of x where the graph is where the equation is defined, right? So because the f function is defined everywhere except at the asymptote, right? So we have already established that x cannot be 3 for our f of x, right? So the domain of f of x will there be x can be an element of any real number, but just not 3. That's all we need. If you plug in any number into f of x, you're gonna get a corresponding y except at 3. So x is an element of a real number except at x equals to 3. Or if you don't want to write it like that, you can say x is either greater than 3 or x is less than 3. Yeah, then that's also true. Let's move ahead. We have 5.3. It says determine the coordinates of the x-intercept of f. What comes to your mind when you hear the word x-intercept? When I hear the word intercept, x-intercept, I think y equals to 0, because an intercept is where the graph cuts on the x, and when it cuts on the x-axis, y is supposed to be 0. So we're just going to take our function and let y be 0 so that we can find the intercept. So for f of x, we're going to have 0 minus 1 divided by x minus 3 plus 2. We subtract 2 from both sides, we get minus 2 equals to minus 1 divided by x minus 3. If we cross multiply that, we get minus 2x plus 6 equals to 1. Take 6 to the other side, minus 2x equals to, this is minus 1, you take 6 and then it becomes minus 6, this will be minus 7, and then x equals to 7 divided by 2. That's the x-intercept, and then the point is, the x value is 7 divided by 2, and then the y is 0, right? Because at the x-intercept, y is equal to 0. That's what we assumed when we were calculating x. The next question, y-intercept, we let x be equal to 0, and then we solve for y. For this equation, we're gonna have y equals to minus 1 divided by x. No, we're letting x be equal to 0, so this will be 0 minus 3 plus 2. This will give us 1 divided by 3, this negative and this negative, and then we have plus 2. And then here, the way I do it, I give 2 a denominator of 3 so that I can just add the numerators, right? So this will be 1 divided by 3 plus 6 divided by 3. This is equals to 2. And then I'll just have 1 plus 7 on the numerator. You take a common denominator, then this will be 7. Oh, this is 6, I'm sorry. This will be 7 divided by 3. So that's the value of y for the y-intercept. Then the point will there be for 0, and then y is 7 divided by 3. Let's move ahead. 5.4. Last but not least, draw the graph of f. Clearly show all the asymptotes, intercepts, and intercept with the x's. So asymptotes and intercepts. Yeah, I'm just writing that down so that I don't forget. Let me increase this space, and then okay, yeah, there we go. We have our y-axis there, and then we have our x-axis there, and then yeah, obviously it's still running, it doesn't end them. Asymptotes. Okay, let's go up and look for our asymptotes. The y-asymptote is 2, and the x-asymptote is 3. So here the x-asymptote is 3, the y-asymptote is 2, right? So if you're dealing with a hyperbola, you will then sort of have a new set of x's, right? That's the asymptote there running, and then this is the asymptote there running. At this point, you should know that when you are given a hyperbola, it's either you will have a graph here and another one here, or you will have one here and another one here. But then what determines that? I determine it using the equation, right, for the function. So let me write that down and take you through it. So the equation is f of x equals to minus 1 divided by x minus 3 plus 2. Look at the x. We have this 3 here, right? So here we have 4, we have 5 going forward. So what we can do is just ignore the 2 because it's a constant, and the minus 3 on the denominator, right? So let's just put minus 1 divided by x, right? If you keep on increasing x here, so x is going up, right? This value becomes smaller and smaller right? But then because we have a negative here, it's becoming smaller from the negative side, so it's sort of increasing in a way, right? So y will go up when x goes up, and then that will mean that when x goes down, y goes down. In the first quadrant here, when x increases, y will go down for a hyperbola, right? On the second, x is increasing, we're not interested on that, and then on the third is doing the same. But then on the fourth, that's where when x increases, y also increases. So the first swing will be this side. Suppose you cut here on the x-axis, and then it will be like that, and then another wing will be on the second quadrant, or made by the asymptotes, right? And then another thing is supposed to indicate is the intercepts. For y, it's 7 divided by 3, so I'm assuming 7 divided by 3 somewhere here, and then for x it's 7 divided by 2, so 7 divided by 2, I'm assuming it's somewhere here. So we have indicated the asymptotes, we've indicated the the intercepts, and yeah, that's it for this question. If you like the video, give it a thumbs up. If you didn't, leave a comment. Let me know what you didn't like.